Hey guys.
Hey Megan.
How was your vacation? Where'd you go?
It was good. I went to Disney. Oh, that's so much fun. I wish I went there. How were your guys' vacations?
Fun, except I had to work in my lab notebook.
Yeah, me too.
I actually have a couple questions on the molecular geometry lab.
Yeah?
What's VESPR?
Well, I know that VESPR stands for valence shell electron pair repulsion.
Oh, but what does it do?
A molecule's shape is defined by how many bonding pairs there are, because they repel each other, forming distinct shapes. Bonding and non-bonding pairs make shapes that maximize the distance between each other.
Wow, that makes so much more sense. But one thing I still don't understand is how it's used.
To determine the 3D geometry of a molecule, draw the Lewis structure for the molecule. Then determine the shape by the number of electron domains. Arrange bonds to maximize distance between each other. Then name the shape.
Oh, but in the molecular geometry lab, what do the different shapes look like?
You know, when I was doing this lab in Disney World, I noticed a lot of connections between the molecular geometry shapes and the shapes in Disney. What do you mean? Like, what about linear?
Well, I know what linear is. The angular distance between the bonding pairs is 180 degrees, and it makes a linear shape, which is just a line.
Exactly, and I remember going on a ride where Pluto was holding a barbell, and it looked just like linear.
Linear molecules have 180 degrees between the electron domains to maximize the distance between them. Which of the following compounds is linear? Beryllium chloride is linear because it has two electron domains between the beryllium and the two chlorine atoms, which repel each other. As a result, they are going to be as far away from one another as possible, on opposite sides of the central atom, making a 180-degree angle.
But what about trigonal planar?
Oh, I know that one. The angular distance between the bonding pairs is 120 degrees for trigonal planar.
Yeah. Oh, and I remember one of the Ferris wheels there had a shape of trigonal planar.
And you can remember that one by thinking of how tri means 3 for the 3 atoms surrounding the central atom, and planar as in plane, like in geometry, so everything is on the same dimension, or flat.
Trigonal planar molecules have 120 degrees between each of the electron domains, because there are 3 bond pairs and no non-bonding pairs. Which combination of these following elements would result in a trigonal planar structure? Boron trifluoride, because there are 3 bonding pairs surrounding the boron atom, so they're going to be as far away from each other as possible, which would make 3 120-degree angles. Therefore, it would be trigonal planar.
What's the one where there are 4 atoms surrounding a central atom?
That one's tetrahedral. Megan, do you remember anything in Disney World that resembled tetrahedral?
Well, Goofy's face and hat kind of looked like it.
Tetrahedral molecules have 109.5 degrees between each of the electron domains. There are 4 bond pairs and no non-bonding pairs. Which of the following is tetrahedral? CH4 is tetrahedral because there are 4 bond pairs surrounding the central atom, so they would be as far away from each other as possible, making 4 109.5 degree angles.
This is making so much more sense to me now. Yeah, but why is water shaped like this?
It's because it has to do with dipole moments.
What are dipole moments?
Some atoms have extra valence electrons, such as oxygen. The extra electrons are grouped into pairs of 2 and are called lone pairs, dipole moments, or non-bonding pairs. The lone pairs repel bonding pairs, causing the molecule to take on different shapes. Which of the following is not dipolar? H2 has no dipole moments because it has no lone pairs.
You can think of the shape of molecules with dipoles by counting dipoles as bonding pairs. So a molecule with 2 atoms bonded to it and 2 dipoles would be a tetrahedral shape. But 2 spaces are taken up by dipoles, which don't count as part of the molecule, so it has a bent shape.
Dipoles fill the space that could be taken up by a bonding pair. So water has 2 bonding pairs and 2 dipoles, so it has a bent shape. Okay, so then you can think of this one as Mickey Mouse and his ears.
Bent molecules have 104.5 degrees between the electron domains. There are 4 electron domains, consisting of 2 bond pairs and 2 lone pairs. Which of the following molecules are bent? C is the answer because sulfur forms 2 bonding pairs with the fluorines and has 2 dipole moments.
In addition to bent, there's one more shape with dipole moments, and it's trigonal pyramidal.
Okay, and trigonal pyramidal kind of looks like Pluto. And this one's easy to remember if you think about tri and the 3 atoms that surround the central atom, and pyramidal has a pyramid shape.
Trigonal pyramidal has 107 degrees between each of the electron domains. There are 4 electron domains with 3 bond pairs and 1 lone pair. Which of the following is not trigonal pyramidal? C. Although boron trichloride has 3 bond pairs, it does not have a lone pair, making it trigonal planar and not trigonal pyramidal.
What about polarity? Does that have anything to do with these shapes?
Yeah.
Polarity is an uneven sharing of electrons between atoms of a molecule. Polar molecules have positive and negative poles, while nonpolar molecules do not have positive and negative poles. Determine the polarity of a molecule by looking at the bonds. Different atoms will have different pull on electrons, making polar bonds. Look at the symmetry of the molecule. If polar bonds are symmetrical, then the molecule is nonpolar, while if the polar bonds are not symmetrical, the molecule is polar. For example, carbon dioxide is nonpolar because there is an even pull on each side, while CSO is polar because the oxygen has a stronger pull than the sulfur. Which of the following molecules are polar? H2O is a polar molecule because although the pull of the hydrogen atoms are the same, the lone pair makes the molecule have poles because the hydrogens are on one side while the oxygen is on the other.
Oh, I get it now.
Yeah, me too. I'm just having trouble visualizing the poles of the molecules.
Well, you can think of this as a game of tug of war between the molecules.
Yeah, you're right.
Really? How?
Well, let's take a hula hoop and jump rope, for example.
The molecule in this picture is carbon disulfide. The hula hoop in the middle represents the central atom, carbon, and the two people in the black represent the sulfur atoms. This molecule is nonpolar. The molecule in this picture is carbonyl sulfide. The hula hoop in the middle represents the central atom, carbon. The person in black represents sulfur, and the person in pink represents oxygen. This molecule is polar because the two external atoms aren't the same, so they have different pulls on the electrons, and the electron distribution is imbalanced.